So when we talk about factoring trinomials, we have a few different things that we're going to have to deal with, but we're going to start with the trinomials with a leading coefficient of 1, and you really do want to spend some time and focus on these and get pretty good at them, because we're going to use a lot of these skills to do some stuff later on, again, and when we get to the next section, actually. So let's go ahead and make sure we understand leading coefficient of 1. So when we look at these, we see that there is no coefficient here, and that tells us that there's, that leading coefficient of 1. So this is a special type of trinomials, and we have some things that we can use to make these kind of nice to do without getting too stressed out. Now, I do want to take a little bit of a step back before we really jump into that. And remember, we're talking about we talked about FOIL in the last chapter, and this is a method that we use to multiply two binomials. We're still going to be able to do that. Again, we're going to be using that to check, but I want to start out with two binomials and go ahead and multiply them together. And remember that this is using FOIL. I'm just going to, remind us that this is what we're doing here. So when we multiply these things together, we get k squared plus 1k. I'm going to go ahead and put the 1 there just for effect. Then negative 3k, and then negative 3, and then we combine like terms, and we get k squared minus 2k minus 3. So this is the multiplying process. Now, when we factor it, we are going back to the double parentheses. We're doing a division process. So let's talk about how we can do that. Now, there are some steps that we need to do. Now, as soon as we know that we're doing most factoring, the first thing we do is do some parentheses, and in this case, this is no exception. So we're going to write our double parentheses. So that's our first step. We just do the double paren. And then the next thing that we do, remembering, keeping in mind that this is a specific type of trinomial where the leading coefficient of 1. So with this type of trinomial, the first thing we do is take the square root of that first term, and we place that root in the first position of each of our new parentheses. So far so good. And why do we do that? Because we know that when we multiply k times k together, we get that k squared. Now we are going to look at 3, and I used a pretty basic example here. The next thing that we do is we look at the 3, and we also look at this. And what this tells us is if we're adding or subtracting the factors of 3. So we're looking for factors of 3 that subtract to this middle coefficient, to the coefficient of the middle term. So we say, what are the factors of 3 that subtract to 2? So the factors, and this is fairly obvious because there's only really one set of factors of 3. So the factors of 3 that subtract to 2 are 3 and 1. Now what we're going to do is a quick little check. We know that we've got a subtraction. We need to subtract these. Remember, what we're looking for are the things that create our middle term. So we just multiply these together real quick. That's 3k. And then we multiply these two guys together. That's 1k. And then we ask ourselves, do these subtract to 2? And the answer is yes. So that means that we've placed everything correctly. The last thing that I recommend you do is deal with the sign. And the sign, that negative disappeared, let's get it back in. The sign is one that we can, again, sort of use the signs that are there. Now, when I say we're using the signs that are there, it's all based on our integer rules. So, when we look at this sign here, and I said we have to subtract them, but when we look at that sign, that second sign, we know that the only way to get a negative when you're multiplying is to have one positive and one negative. So when the second sign is negative, like this one, we know it has to be two different signs. So it has to be one positive times one negative. And that's our integer rule. That's the only way to get a negative product. Now, when we look at the first sign, that tells us what the bigger product is going to be. Because remember, when you are adding these two things together, again with the integer rules, when we add two numbers together that have unlike signs, we take the sign of the larger. So we need a negative here. So that means the larger one gets the negative, the smaller one gets the positive. So that's, where did this come from? Where did this product come from? From these two, so that's the negative. This product came from these two. My negatives keep disappearing. So that's the positive. And if we remember, that's exactly what we started out with, so we can see that. Okay, we'll do more practice later, but I do want to make sure in this intro video to this section that we remember a few details. And one of them, of course, is that we always look for the GCF. The last one I used was a pretty simple example, but when we look at this one, we see that we've got a 3 out here. Well, hopefully that's obvious that that's not a coefficient of 1. Later on, we're going to be working with these, but the first thing that we do, no matter what, whenever we're factoring, is we look to see if there is anything that we can pull out as a GCF. So as we look at this, as we look for the GCF, we see that we've got a factor of 3 in all of them. So there's part of our GCF. And then we also see that we've got a variable, the x, in all 3. So the smallest is the squared. So there is our GCF. Now remember, we divide that GCF out. And we are left with x squared minus 5x plus 6. So now we look at this and we say, all right, can we factor out what's in the parentheses? So we took out the GCF, and now we want to see if we can factor this. So again, I just bring this down because I just don't want to leave it behind. So I'm bringing it down so we can see it a little bit better. So let's see, we'll go ahead and bring this down. Now, how do we know if it can be factored? Well, we never really know for sure, so we always have to try. So I'm going to put my double parentheses down. Now, it is a leading coefficient of 1, so we know that we're just going to put an x and an x, because x times x gives me that x squared. And then we look at what we've got here, and we say we're looking at that that third term, and we know that we're looking for factors of 6 that add, that's the thing that tells me I'm adding, to 5. So the factors of 6 that add to 5, sometimes it's nice to write the sets of factors down. So we've got 1 and 6, we've got 2 and 3. Which of those add to 5? Well, that would be the 2 and the 3. So we go ahead and put the 2 there, the 3 there. It doesn't matter where the 2 and the 3 goes because we haven't placed the signs yet. That's one of the reasons I kind of like to hold off on that. Now we're just going to do our, this is the OI part of the FOIL because we're just checking it. Again, remembering that the second sign tells us that we are adding. So we need these two products to add to whatever that middle coefficient is, which is 5. So 3x and 5x is, 3x and 2x is 5x. So we know that we've got them, everything's placed correctly, the numbers and the variables and everything. So now we go back and we say, okay, remember again, we're going back to these signs to tell us what happens with the signs. Again, we have to think about the integer rules. So the only way to get a positive is to multiply the same sign. And that again goes back to the integer rules. Like signs, when we multiply them, gives us a positive answer. That means, this means that both of these signs must be the same for this to become positive, for the 6 to become positive. When we look at this, remember that we have to add these two products together. So we know that we want a negative, so they should both be negative to get that negative. Again, integer rules. And the only way for us to multiply that 2 and the x together and get it to be negative is to have this be negative. And of course, the last step that you always really want to take here is you multiply it back together to make sure that you're getting what you are supposed to be getting, or what you started out with. All right, let's do another one. Here we've got another trinomial, so we're looking for a GCF first, of course, and we see that we don't have one. We can tell because of the fact that this last term doesn't have a variable and this first term doesn't have a constant. It has to be in all three things, or all of the terms in any given polynomial. And so we just don't have a GCF, so we skip that step, but we have to look for it. And now we just factor it. So I'm going to put the m squared minus 2m plus 5. Now I'm really encouraging you to think about how I was speaking in the last one and then how to identify things. But if we look at the first thing, we say, okay, I put in the m and the m there. Now our next step after we get that done is we ask, what are the factors of 5? I'm just going to write it so you see it. Factors of 5 that add, we're reading backwards, to this middle coefficient that add to 2. So the factors of 5 that add to 2, and you think about that and you might scratch your head a little bit, but the fact of the matter is that there are no factors of 5 that are adding to 2. The only factors of 5 that we have are 1 and 5, and 1 plus 5 will never be 2. So what have we done here? We've just proved that this is not factorable. And when we use that method, we can prove that something can't be factored. Sometimes we like to call it prime, whichever one is fine. But we can prove prime. You can't just guess or assume prime. You have to prove it. And this is one really great way to do that. We're going to do just a couple of examples together just to make sure that you're doing a little bit of work before you start trying to do them on your own. Again, we see it's a trinomial with a leading coefficient of 1. As soon as we see that, we know we've got our double parentheses. We get the square root of the first term, so that's x and x. We look at that third term and we say, what are the factors of 2 that add to 3? The factors of 2 that add to 3, well, there's only 2 factors of 2, and 1 times 3 is 2. And do those 2 factors add to 3? They certainly do, so we've got 2 and 1. Now again, the second sign tells us that the signs have to be the same. The first sign tells us what the signs are. So the second sign says they're the same. The second and the first sign tells us they're both positive. Again, the next thing that you should always do is multiply these guys back, FOIL them. So we have x squared plus 1x plus 2x plus 2. Combine like terms, x squared plus 3x plus 2, and it should be exactly the same as when you started. Let's do another one. Again, leading coefficient of 1, trinomial, so we put the m and the m. The factors of 14 that add to 9. Factors of 14 are 2 and 7. They add to 9. Again, the second sign is a plus, so they have to be the same. The signs have to be the same. And the first sign is a plus, so they are both positive. And of course, your next step should be to multiply it back. I just don't want to spend the time multiplying all these back because I don't want to waste your time watching me do that when you can just do that very well on your own. And then let's go ahead and just do this last one. This one has a negative, so it's a little bit different, but same principle involved here. Let's look at our leading coefficient of 1 again. So the square root. Now the factors of 15 that subtract to 2. Again, we've only got 1 times 15 and 3 and 5. Which of those subtract to 2? There we go. So we know that it's going to be 3 and 5. And then we know that the signs have to be different because that negative, there's only one way to make 3 and 5 when we multiply them together. There's only one way to get it to be a negative number. That's for the two signs to be different. And then we look at the first sign, and the first sign tells us whatever the bigger product is has to be negative. So how do we find the bigger product? We multiply these guys together. The bigger product is the 5p, so that means that has to be the negative, that has to be the positive. When we add these two guys together, it should be our middle term, and sure enough it is. So the negative 5p, that negative comes right here, and that's got to be the positive. Again, FOIL them back just to make sure.